Hello class, today we're going to talk about section 5.5, which is absolute value inequalities. By the end of today's lesson, you'll be able to solve and graph the inequalities that involve absolute value. Quick review of what it means to have an absolute value. That is the distance the number is away from zero. So go ahead and quickly answer, what are the two integers that have an absolute value of 34? The answers are 34 and negative 34. Another quick review, when we are solving absolute value inequalities, there are two cases. Case 1 is setting it equal to the positive value. So we're going to go ahead and take away 6, and our first answer would be x is equal to 7. Our second case, we would set it equal to the negative value. Again, subtracting 6 from both sides, we would end up with our second answer of x is equal to negative 19. So, with inequalities, there are actually two different types of problems we are going to look at. If we start with the less than, or the less than or equal to symbol, it's going to fall under the and or the intersections type of problem. If we start with a greater than, or greater than or equal to, we're going to start with the or the union type of problems. In either case, or in either type, you still have two cases. Just like we had two cases with the equations, we're also going to have two cases with the inequalities. Again, case 1 stays positive, just as case 1 was positive over here, but that inequality symbol is going to stay the same. So we're not going to change anything. For case 2, our answer becomes negative, just like it did for the equations, and we have to flip that inequality symbol. So when you are doing case 2, make sure to make the answer negative and flip the inequality symbol. So this is kind of a visual to help you remember what symbols or which inequality symbols are going to be associated with your answers. So if you're under the and case, so we start with the less than, then case 2 is going to be the greater than. There is going to be overlap as part of your answers for this one. So you're going to have answers that overlap, and you're going to need to highlight that, just like we did with the last lesson for the compound inequalities. Over on the or side, your first case is going to be greater than, your second case is going to be less than, and there will be no overlap. So there's no extra shading if you start with the greater than. So, for example, we've got the absolute value of 2n minus 18 is less than or equal to 2. So this is putting us under that first case, which is and. So we're going to start with our first inequality and say 2n minus 18 is less than or equal to 2. And then we're going to say and case 2, we're going to flip it and say 2n minus 18 is greater than or equal to negative 2. So notice how I just set up case 1 and case 2. I haven't done any solving. I really recommend that you take the time and do this step so that you know the two inequalities that you are looking at. The next thing you're going to want to do to solve both of them is add 18 to both sides. So for case 1, I've got 2n is less than or equal to 20. And for case 2, I've got 2n is greater than or equal to 16. Then I'm going to go ahead and divide both by 2 to finish solving. For case 1, I get an answer of n is less than or equal to 10. And case 2, n is greater than or equal to 8. Now, remember, this is an and statement. So when I graph my two inequalities, I'm going to have a closed circle at 10 and a closed circle at 8. We want it to be less than 10 and bigger than 8. So we are only concerned about that overlap area. So our final solution for this AND case is only between those 2 points. If we look at this problem, we're starting with a greater than symbol, which is going to indicate to you that this is an OR problem. So that greater than symbol is telling you that it's an OR problem. Again, I highly recommend taking the time to write out your two cases. So that first case stays the same and the number stays positive. The second case, the inequality symbol flips and the answer becomes negative. To solve both, we're going to subtract 3 from both sides of our inequality, and I end up with 3x is greater than 15, or 3x is less than negative 21. Continuing to solve, I've got dividing by 3 on all of our answers, and I get x is greater than 5, or x is less than negative 7. Again, this is an OR statement. So I've got, when I come down to my graph, first one I've got is x is greater than 5. So I've got my open circle, and it is getting bigger. And then then case 2, I've got x is less than negative 7. So we are going to the left. Since it's an OR, there's no overlap that I need to worry about or no extra shading. Go ahead and try this one on your own, determining if it's and or, and then solving the problem. Because it starts with a greater than symbol, it is an OR. Solving case 1, you get y is greater than or equal to 2. So that's that green arrow down at the bottom. And solving case 2, you get y is less than or equal to negative 4. That is that purple arrow down at the bottom. If you have questions about this, please let me know when you get to class. Just like with equations, you will find that some inequalities are set equal to a negative to start with. This is going to indicate two things depending on which way the symbol is going. So we know that absolute values are always positive. So right now it's saying that a positive is less than negative 3. It's never possible for a positive number to be less than a negative. So this should indicate to you that there are no solutions to this particular absolute value inequality. On the flip side of that, if I have a positive value is greater than a negative value, that is always going to be true. So this is all solutions. Putting that into helpful notes, the absolute value is greater than a negative, it's always all solutions. If the absolute value is less than a negative, then the answer is always no solutions. Final thing we are looking at here is writing out absolute value equations, or excuse me, absolute value inequalities based on the graphs. So just like when we did this with equations, the first thing we need to do is find the middle number. So the middle of our 2 points. So our first point that we've got here is negative 6, and the other one is 2. So we're going to go ahead and add up negative 6 plus 2 and divide by 2. Negative 6 plus 2 is negative 4. Dividing by 2 gives us an answer of negative 2. So that means our mean of those numbers are negative 2. Then if you recall from what we did with our equations, our goal is to figure out the distance between the points. So between negative 6 and negative 2, there's a distance of 4. Between negative 2 and positive 2, there's also a distance of 4. The one thing that we really have to be careful with now is when we are writing our final equation. So just like with the equation part, I have x minus the mean, or minus that middle number, is in the absolute values, and the distance is off by itself. The symbol that you are going to plug in between is going to depend on you recognizing the type of graph that we have going on. Because the arrows are going in the opposite direction, and there is no overlap, that means we are in the OR case. If you look back on that chart that we have from the first couple of slides, if we're in an OR, that means we're starting with a greater than. So in this case, I'm going to say the absolute value of x minus -2, that's in the absolute value, is greater than or equal to. So it's greater than because we have the arrows going the opposite direction. It's equal to because we have filled in dots up here. These were filled in to start. And then our distance was 4. Minus a negative turns into a positive. So our final answer is the absolute value of x plus 2 is greater than or equal to 4. Go ahead and try this one on your own. I want to note that this value here is -13, and this one over here is 9. So, -13 plus 9 divided by 2, again, gives us our middle point of -2. Our distance between both of those is 11 spaces. So our distance is 11. Because there is overlap in the middle of the points, that's going to indicate to you that it's and, which means that it is less than. It's open dots, so there's no equal to part. So our final answer down here, x plus 2, again, minus a -2 turns into plus. The absolute value of x plus 2 is less than 11. If you have questions about this or any other part of the lesson, please let me know when you get to class.